In this class we will see how to analyze mechanical effort in parts with SimulationXpress, which allows to analyze the resistance of parts according to the material and the applied efforts. Check the tension and detect critical regions, enabling changes in the model still in the design phase, eliminating reworks subsequent and unnecessary costs. We will simulate an I-beam set at both ends and subjected to a load distributed on its upper face, analyzing the resulting tension and critical areas of the model. Open the available file and let's get started. In the Tools menu, under Express Products, we click on SimulationXpress and note that the wizard is shown in the task pane. In Options we can define the system of units, the location to save the results, and if we want to display the maximum and minimum values when plotting the charts. Clicking on Next, we proceed to the next stage, which is the definition of the fastenings of the part. Since the crimping is characterized by restriction to movement on both axes and also restriction on turning, we click on Add a fixture, select the faces of the rafter ends and set them as fixed. See that we can access the analysis settings on the left side of the screen. We click on Next and now we will apply the charging, which can be strength or pressure. In our case, we will apply force, then click on Add a force, select the upper face of the beam, type 30,000 for force in newtons and confirm. The next step is to set the beam material. See that we already have material applied to the piece, but if necessary, it can be changed easily by clicking on the option shown. We choose IC 1045 and move forward. Using the standard mesh of SimulationXpress, we perform the analysis. After the simulation is complete, the results are generated and the part is displayed animated. We click Yes, Continue, and now we can view the results by expanding the Results folder. See the deformation result and note that due to the crimping at both ends and the applied force, the beam tends to deflect. And the maximum value of this deflection occurs in the center of the beam. We activate the voltage result, noting that unlike the maximum deflection, the maximum stresses occurred at the ends, where we have the fixation of the faces. Note that warm colors indicate the regions of greatest stresses. However, in this case, the voltages obtained are considerably lower than the flow voltage of the material and the safety coefficient is very high. What is indicated now is to carry out the optimization study, but we will not show it in this course. After checking the results by clicking on Done Viewing Results, we can generate a report of the analysis by clicking on Generate Report. By clicking Generate, the report is generated and opened in Microsoft Word. You can generate the eDrawings file from the simulation by clicking on Generate eDrawings file. By clicking Next, SolidWorks asks if we want to optimize the model. This subject will not be dealt with in this course, so we select No and click Next. See that the assistant informs us that the simulation is finished. If you want to redo it, just click Start Over. We finished this lesson, where we learned to use SimulationXpress, remembering that we should do the project calculations and compare them with the results of the simulation.